Hello and welcome to the video about reporting the center for a symmetric distribution. If it's symmetric, we use the mean, okay? Especially symmetric and unimodal. So let's go through the steps. We're going to get some data. Either we collect the data or the data is given to us. Okay, if there's no display already, we need to make a display. Okay, I'm just reviewing here. We have a histogram, we have a dot plot, and we have a stem and leaf plot. Okay? Here, let me spell this out. Stem, leaf. Okay? So now that we have this display, the first thing we have to do is describe the shape. Because the shape's going to tell us what statistics to use. Okay? Next we have to do unusual features. This is also going to tell us what to use. Okay? If there's a bunch of outliers, we're going to use the median and the IQR. If the shape is symmetric, we're going to use this mean. If the shape is skewed, we're going to use the median and the IQR, which we've already talked about. Okay? So 3, we have to describe center / spread. Now it's very important that you know, okay? We're going to report the mean and the standard deviation. We're going to report these. This is 2 different statistics. Okay, 2 different statistics. We're going to report these 2. Data is symmetric. It's very, very important. Okay? All the time. All the time. Okay, you could use the median and the IQR, but this is the one you want to use. Okay, so generally if our graphs look anything sort of like this, they look like this, we want to report the mean and the standard deviation. Okay, so the mean is reporting the center, so it's the same kind of idea. It's the typical distance. Okay, and this is how we do mean, just like that. An X with the line over it, and we call it X bar. Okay, and I got a video on how to find it by the calculator and by hand. You don't necessarily have to do it by hand. Okay, you guys know how to find the mean. That's the average, and that's just adding all the data points up and divide them by however many data points you have. This is the data points in the set. This is the number of data points in, we could say, the sample or the set. Okay, so how are we going to report the center? You go ahead and find it. So you find the shape, you look at the graph, look for anything unusual, and we're on center now. That's going to be our last video. We're talking about center. So you go in your calculator and you find the average. Okay, if you got 2 distributions, you're going to find both averages and compare them. Okay, the men's size, the average of the men's shoe is greater than the average of the women's shoes, and you would find average if both of those distributions were fairly symmetric. Okay, so we're doing center. You would say, this is how you'd write it up in your report. You would say the mean of the, okay, now we're going into our W's. What are we measuring? The mean of the what? That's what we're measuring. That's the variable we're measuring. The mean of the what? The mean of the, let's say, heights of the, who are we measuring it on? Is about whatever it is. Okay? Is about whatever it is. Okay, because you have to find that. Okay? So for the X bar, that's almost it. We have to kind of see what it looks like. What would happen if it was skewed? And why one of the reasons we don't use it if it's skewed. So I'm going to give you a distribution. You tell me what shape it is. Okay? So this is skewed. It's either skewed right or skewed left. So you look at the tail. You look at this tail. Is the tail going to the right? Is extending it on the right? Yes. So this would be skewed right. That's a concept you have to know. So put a little star by it. Oh, what am I doing? I'm telling you. I told you guys today. I say things and write things. If I just confuse you, the tail gets kind of extends out here on the right, so it's skewed right, not skewed left. I'm not sure if I said left. Okay? Skewed right. Okay, so the way the mean works is the mean is like a balance. when you're looking at histograms or any of these stem leaf plots, dot plots. They all look the same, because if this was a dot plot, it would just kind of look like this. It looked sort of the same. That's what the dot plot. So it's like a balance. It's like if these all weighed, not weighed the same, but if these heights represented weights, okay, so for example, this little weight would be a lot less than this big weight. So if I put this pointer right here as a balance, this thing would just fall down. Okay, so it's like, where should I put this? Scan across this. Where can you put it to kind of hold it up? Okay, and I would probably come right about here. Let me switch my colors up. Maybe right about here. So if this was a balance, maybe even a little more this way here, but somewhere around here. Okay, let me just change this up a little bit and see what I'm doing. Yeah, I'm going to go with this point right here. This would be my X bar. Okay, so just like if you had this data, so I'm going to write this. I'm going to show you why the mean pulls towards the skewness. What I mean is that these are small numbers, these are large numbers. The mean will get pulled up with these numbers, even though they don't happen that often. They're going to pull the mean up. It'd be like me saying this: 5, 5, 7. So I'm writing all small numbers now, right? I'm writing all small numbers. Okay, so I have a lot of 4s and 5s. Now what happens? I'm going to introduce a few different numbers. I'm going to say, okay, now I got an 8, a 9, and an 8. Okay, so if you got the average of all these numbers right here, these numbers kind of represent the heights of these guys right here. A lot of stuff that's small happening, and these numbers over here kind of represent this tail. There's some big numbers that don't happen that often. So what are these big numbers going to do to the mean? They're going to make it larger, because you see, the average of this might be 5. But when you include 8, 9, and 8, it's going to make that 5 maybe go up to 6. So this would be the right tail, where this would be these guys, and this would be these tails right there. Okay, so when the data is skewed to the right, the mean gets pulled larger. I was going to do a video on this, but I'm just going to do this now. If data, or maybe I will, if data, see, I did it again. If the distribution is skewed right, the data can't be skewed right. If data is data, right? Data is data. How can the data be skewed? Data can't be skewed. If the distribution of the data, if the picture of the data is skewed right, okay, write this down and put a star by it. The mean, that's the mean, will be greater than the median. You see? Because if you look at this as a 50%, 50%, the median's going to fall right here. So the mean is bigger, okay? And it's the opposite for skewed left. It's the opposite for skewed left. These are good things to know. So if the distribution of the data, try to practice a skewed left. See if you could draw a skewed left. Okay, then, okay, so the X bar will be less than the median, because it gets pulled. It's almost like if the whole class got hundreds and you have one kid that doesn't study. If the whole class gets hundreds and you have these few that didn't study right here, okay, so say this is in between 30 and 40 and there was only one person, okay, but most everybody did really, really well. What's this one, let's call it a 32. He got 32. What's this 132 going to do to your average? Because look at the average of all these guys. If you forget about here to the left, that's a nice symmetric graph. Okay? If I get rid of, I know I'm getting a little long, I'm almost done. If I just cut this right here, okay, and excluded everything to the left, this would be a nice Let's say this is 80 right here. The average would be 80. But now let's not do that. Let's go ahead and keep. What happened? I know I just did that. Let's add all these lesser values in. What's it going to do to this average? Okay, it's going to make it smaller. So the average here would be somewhere right around here, 70. And if you did the shading rule, the 50-50, this would be your average, and this right here would be your median, maybe 75. Okay, so skewed left, the x-bar is less than the mean. Alright, so that's it on the mean. We got one more, which is the standard deviation. Remember, the mean, the x-bar, always gets reported with the standard deviation. That's how we write standard deviation. And then that's going to be a little bit long because this is the most important concept of the whole class. Okay, right here, standard deviation, because most of our data is going to look like this, because there's a way to make it look like this, which we'll learn later in the year. Alright, bye. Thanks for watching.